Hello again, everyone. So in the previous in this video here that I'm going to show you how we can implement a Python object that we're going to call it network that will package all the loose work that were done in a previous video. Let me refresh your memory. The previous video we considered a small network or a graph, and we implemented that using Python dictionary, and we're able to use the Python dictionary features to identify the keys, which are the nodes, and the values, which are the neighbors of a given node. So A here had C and D and B neighbors, and if we go here, A has a C and D and B, exactly. And then we were able to pass this dictionary to the constructor of network X class that is called, or object that is called graph. And we're able to enjoy some of the features that network X is giving us. But before we lean too much on network X, I really want to show you how we can implement our own objects and our own networks. And let's get started. So I'm going to define a class, and I'm also going to call it a network as opposed to graph. And why am I calling it a network as opposed to a graph is because network X uses the word graph, and I don't want to create another object and then call it graph. And then if we want to use both, we get confused. So to distinguish the work that we're going to be doing here, I wanted to make sure that that we see the difference between what we're doing versus what network X is offering us, because we're going to be alternating. Obviously, we cannot implement the entire library. We're going to be using a lot of the built-in functions that part of network X. But the more we do things by our hands, the better we understand how networks work and how we develop some good understanding. So the thing that we need to add immediately to the class is the dictionary as an instance variable here. And we're not going to add it here outside the init function. We have to add it inside, so every object will actually have its own dictionary. Because if you want to create multiple networks, then every network will have its own dictionary. And the init function here takes self like that, and it will take the dictionary to populate the instance variable here. So this is going to be the concrete dictionary like that, and the concrete dictionary is going to populate the actual dictionary that belongs to each object that is part of the class. That's why I'm going to distinguish it by the word self dot underscore underscore. What do we call this? We are going to call this my graph. We're going to call this is the graph here. So what I'm going to do is basically, and as you can see, the graph here is something that's a variable, a local variable, an instance variable, part of the network class, but it will not really conflict with network X, because first of all it's inside here, and then we at this point we can actually start doing the set and get. We can define set set the graph, and set the graph is going to take this graph here and is going to this will be the new graph like that, which is essentially a dictionary that we're going to pass to the graph. This is how we set, but also this function needs a self parameter as well. Now we also need to return the graph when we say get that graph that belongs to the network here. So what we need to do is to define a get graph like that, and this function does not take any parameters other than the self dot get underscore underscore graph, and we actually need to return that. Okay, if we actually do this just by itself, I think this can be really good. Okay, and now what we need to pass here is actually a dictionary. There's nothing in Python that will tell us or will force us that we need to pass a dictionary, but let's do it. So for the sake of being really quick, I'm just gonna copy the dictionary that we used here last time in the previous lecture, like that. And now I'm going to create a network object like that, and my network object is going to take the dictionary here. We can call it just a simple graph here like that. So I'm in this network X. So this is how I'm instantiating that. So we can call this collab graph like that. Basically for collaboration, for collaborators graph, as we mentioned here, because this was a network of collaborators. So that's why I'm naming this collaborators graph. So now we're instantiating our network object here that we created, and we're passing this dictionary here to make it fully populated, and this is supposed to give us an object. Let's run one cell at a time. Running the first cell, we don't have issues. Second cell, we don't have issues. Third cell, we don't have issues. Very good. Now if I say get me the graph, we have a function here that says get the graph, and it worked. As you can see, it has given me all the actual components as part of that. Now suppose that I don't wanna create a graph as big as this, and I wanna create another graph, and I wanna set that graph. So let me just create another graph. I'm just gonna call it graph 2 or neograph like that, and I'm just gonna remove these guys like that. So my graph looks smaller, and now I'm going to set that graph. As you can see here, I'm gonna call the set graph like that, and I'm going to pass this function here, but I have to run now the first cell. So this one is good, and let's run this guy. This one is good. So let's now call the get function, get underscore graph, and see if it's going to return this guy to us or not. Very good. Okay, so why don't we print something as nice as this function here that's called info. This info here returns a name of a graph, and also if the graph has a name, and it returns the type of the graph, and it returns all kinds of information, number of nodes, number of edges, and the average degree. Why don't we do some info like that? Well, first of all, our graph does not have a name, so do we want to give it a name? Why not? So now we are going to do the self dot underscore underscore name. So we want to distinguish the instance variables that belong to the class, and here's the name that we are creating, and we are going to do exactly the same thing that we did for the dictionary. We're going to add a set and get functions. Set name like that, and the set name is going to take the self and the new name that we're going to use, and is going to take that name here and pass the new name to it. new name, like that. We also going to do the same thing for retrieving the name. So we're going to define a get name function like that. And this is going to take a self. And this is going to return the actual name here. Okay. So if we run this one more time, one cell at a time, we run this first cell here, we have no issues. And I'm going to run it again, and run it again, and run it again. It seems, yes, this one is having a problem now because I did not, now this constructor is expecting me to have two different parameters. So the first one, I'm just going to give it a name because it is expecting the first parameter to be the name of the graph. So I'm just going to call this collaboration network. Right, we call it collaborators, it doesn't matter. So if we do that, we get the graph. These are the actual nodes. And let me now get the name as well. So if I call get name dot get underscore name like that, it's gonna give me the name of the graph which I passed here. Now I want to create. I want to demolish this graph here, and I actually want to make it populated by a smaller graph. So here's my smaller graph. So I run it, so I don't have any issues with that. Now I want to set my graph with this smaller graph here. So let me do that. And let me get that graph one more time. So I gotten the new graph, which is, it has 1, 2, 3 records, or it has 3 different elements, which are 3 different nodes. Now, suppose that I want to call this collaborator network as opposed to collaboration. So now I'm going to grab the graph object, and I'm going to set the name like that. And what I'm going to do also is to pass the new name. So we're going to call this collaborators. Excuse me. Collaborator network. So now if I get the name after I set it, I should be able to see collaborators versus collaboration. So this is really great. I would like to leave you guys with this so far, and next time we are going to try to build a function that gives me information about the graph in the same way Network X give me this kind of information here. So we're gonna see this next time. Thanks for watching.